Hello my dear students, welcome to Learner's Planet. Students, we are going to study about force, work and energy. So children, you know that in everyday life we see and perform many actions that involve a push or a pull. So what does this actually mean? What is the actual term given for push or a pull which is acting on an object? Let us start with today's session and let us learn about force, its types and its effect. Now, let us study about the effects of force. Yes, children, the forces cause acceleration or deceleration, right? We cannot see force, but we can see its effects, and that is why we are going to study about its effects. The effects that a force can have on objects are, first one is the force that can change the direction in which an object is moving, right? So there are some examples like, yes, can you see here? This is a baseball ground. And what can you see over here? Yes, when a person throws a ball, actually he or she puts it in motion and the position of the ball changes. So can you see here that there is a baseball player, right? When a baseball player runs around the bases, like this one, this position, runs around the bases, her position changes, right? After some time, you will see that this girl has reached over here. And now she is standing and waiting for the ball to be caught, right? So we can see such examples that describe the motions of different objects, right? Here you can see one more thing, that a girl is batting. She is a baseball player, and when the ball comes toward it, she bats and the ball swings. So the motion of the ball changes, and even when she runs, the position of this baseball player changes, right? Here she is running, but here she is steady. So first she is applying force, a lot of force, a lot of energy is applied. And after that, when she is standing over here, less force is applied. Right? We can see some more examples. Like here you can see that a baseball player is running. Yes. And when he is running, actually the position is changing. Right? So what we can say, this is the effect of force. That a force can change the direction in which an object is moving. Here you can see that the direction of the ball changes when a baseball player hits it with the bat, right? Here also you can see that a baseball player is standing still, right? His position is not changing, but he is actually moving and applying force. But here he is not applying force on an object. He is only applying force on himself to catch a ball. As here you can see that a baseball player is running and his position is changing. So effects of force includes the change of direction when an object is moving, and it also includes the position, right? Here you can see some more examples, like a top spins around and around, and a swing moves back and forth. A clock, pendulum moves side to side, and whenever you do jumping jacks, you move up and down. Whenever you ring a bell, you're actually applying force, right? When you are rolling on your skates, that is also a type or an effect of force. That means you are applying force on an object and the object is moving, right? So all these are examples of one such force, the effect of force, which causes the change of the direction. Secondly, we can say that a force can also change the shape of an object. There is a very best example of one such duff that a chef is trying to make a chapati, right? And you can see here that because of his action, the shape of the duff or the shape of this roti changes or the chapati changes. Here you can see when applied force on a small piece of duff, what happens? Yes, it converts into such shape. It changes into such shape. So what we can say that a force can change the shape of an object. While making chapatis, the force applied by the hands changes the shape of the duff. Thirdly, what we can say? What is another type of effect of force? Yes, a force can make a moving object slow down or stop. Like a girl is skating over here, right? But after some time, when she will move down this sliding rod or this slanting rod, she will stop herself from rolling the skates. Here you can see that there are some shells, right? And there is a ball in the shell. First, we are making it stationary, but then we are moving it, and again it is coming to its original position, that is, it is stationary. So whenever we are applying force, we are able to move the shells, right? In this picture also you can see that a man is applying force. So first, this object is stationary, and after applying force he is able to move the machine. But when he applies less force, this moving object will slow down and finally it will stop. Here you can see one more example that a man is driving a car. But after some time, when he reaches the destination, he tries to slow down his car and finally he stops. So he is actually applying the force on the gear of the car and on the brakes of the car, which makes this car slow down or it stops it down. The fourth effect of force is that a force can make a stationary object move or make a moving object move faster. So that means if the force is applied in the direction in which the object is moving, then we can make that object stationary. So here you can see that first the car is in the stationary mode, or we can say that this is a stationary object. A man is not driving the car, but when he accelerates it, he applies force. He is able to drive the car. That means a stationary object has started moving. And now when he accelerates more and more, then when he speeds up more, then this stationary object is able to move faster. Like you can see here, a music player and a boy. A boy is able to dance, he is able to spin faster and faster while the music is going on. And after some time, this spinning will stop because he will apply less force. But he is applying on himself. Here we are talking about an object, right? So can you see here? There is a difference between these images. We are talking about an object but not a person. So here what we can see? That a boy is able to spin the globe, right? And you can see, you can observe, just observe it carefully, that he is able to spin the globe, but after some time it slows down on its own, right? And finally, when this boy will stop moving this object, this globe, when he will stop spinning the globe, it will come into a stationary mode. That means when a force is not applied, a moving object will come to a stationary mode. And the stationary object can be moved faster or it can be slower down when a force is applied. So this is all about the effects of force. Yes, here are some examples. Like this boy is applying force on the wagon and the wagon is able to move even with a person on it. Here you can see that first the person was not doing the work. He was only holding the machine and the object was in a stationary mode. But when he starts working, the object is not in a stationary mode and it is moving, right? But this is a steady object. Here we can see that the object is itself moving when applied force on it. Here we can see that a girl is playing with the ball. The ball is going up and coming down again. So actually a girl is applying force on the ball and that is why the ball is able to go upwards. And after that it comes down. So whenever it goes up, more force is applied and that is why a ball is able to go up at a higher speed. But when it comes down on its own, it is actually, what is happening? A force is not being applied but it is coming down by itself. How does it come down by itself? Yes, some force has been applied. There is a type of force which is acting on it, which is acting on all the objects on the earth. So we will study about the types of force, right? By which we can get more clear with this. So basically we can say that forces applied on an object cause it to move. That means the direction changes, the shape changes. So all such things changes when force is applied on it. But there are some types of forces. We need to know that what type of force is acting on what type of object. Right? And that is why we have classified it into 4 types. So basically there are many types of forces, but we are going to study about some of the forces. As you know that forces are a big part of physics. So this is devote a lot of time to the study of forces that are found everywhere in the universe. The forces could be a big, such as the pull of a star on the planet. Forces could be small. So forces are actually acting everywhere in the universe at all times. For example, if you were a ball sitting on the field and someone kicked you, a force would have acted on you. As a result, you would go bouncing down the field. So there are often many forces at work, and physicists might not study them all at the same time, but even if you were standing in one place, you would have many forces acting on it. And those forces would include gravity, the force of air particles hitting your body from all the directions, as well as from the wind, and the force being exerted by the ground known as the normal force. There are some forces which attract some things, like magnetic force, and finally the electrostatic force, right? So there are different types of forces: gravitational force, normal force, magnetic force, and electrostatic force. So we are going to study about them in detail. So let us start with the first force known as gravitational force, or it is also termed as gravity. It is a force that attracts objects to the center of the earth. Gravity is a key force in the universe, and it is the force which brought our planet into existence. How interesting and how amazing! So gravity is one of the simplest forces, and it can be illustrated through the classical story of Sir Isaac Newton and his apple. Now just imagine that this is a scientist. He is Isaac Newton. So the story goes like this, that Newton was pondering one day under an apple tree when one apple fell down and struck him on the head. And this set him thinking about the fact that there is some force acting on the objects to pull them downwards. Otherwise, why would this apple fall on my head? And that too automatically? I didn't order the apple to fall on my head. So, how did it fall down? How it struck on my head? So this was the thing that Sir Isaac Newton set him thinking about this, that there is some force acting on the object to pull them downwards. And that is why he concluded that gravity is such a force. Gravitational force is a key force which acts in the universe, and it is that force which brought our planet into existence. So we can basically say that everything in the universe has a gravitational pull which drags other objects towards its center. And because we are living on a huge object, that means this planet, we are subject to its gravitational pull. For example, the moon is also a subject to the Earth's gravitational pull, and even the Earth is a subject. Gravitational pull of the Earth is acting upon all such objects which are on Earth. And even the Earth is held in the orbit by the Sun's gravitational pull, as you can see here in this picture. So we can basically say that these forces are always the first one that anyone names when I tentatively ask about the types of force. Gravitational force. When I ask for direction, I usually get down and occasionally get towards the center of the earth. Of course, I am exerting a gravitational force back on the earth which points in neither of those directions. But that idea is that the gravitational force is actually acting upon us. And towards the center of the object, exerting the force is a pretty decent idea for our starting place. So we go with something like that. So what we can say, that we usually settle on something like near a planet, which is in fact always true for them, for the scientists, that some pull is acting on the earth, and that is actually the gravitational pull, the gravitational force the gravity, which drags other objects towards its center. Right? Yes. Even we can say that the force of gravity is the force of attraction between all the objects and the earth. This one such picture you can see here. Now the ball is moving, but after some time this ball will also go down into this web, right? Because of the force of gravity. And here a force is being applied by a girl onto a ball, and the ball is able to move upwards, but it is coming down by the force of gravity. Now the second type of force which we are going to study is normal force. Now what is this normal force? You must be thinking that what is meant by a normal force? Yes. We will take here an example, like a book resting on a table has a force of gravity pulling it towards the earth, but the book is not moving. So there must be some force which is acting on the book. And what is that type of force? Yes, it is the opposing force, right? Why the book is not moving? Because of the opposing forces which are acting on the book. So this force which is caused by the table to move the book is known as normal force. But then too, this book is not moving because opposing forces are acting on the book, right? For example, here is a thin piece of wood which is supported by both the ends, right? And when we place a small heavy object in the center of this thin piece of wood, what happens? Yes, obviously a small heavy object wants to straighten out, so it exerts an upward force on the object, and this upward force is termed as normal force. That means we can feel the force by ourselves if we push down in the center of the piece of the wood. If we push down this small heavy object in the center of the piece of the wood, so the harder we push, the more the wood bends and the harder it pushes back. So this upward force which normally acts by a small heavy object is known as normal force. So that was about gravitational force and normal force. Now we will study about the third type of force, and that is magnetic force, also termed as magnetism. So it is the force, the magnetic force is a push or the pull applied by a magnet on metals or on other magnets, right? It is a force that attracts or drams in an object. So we can say that magnetism is another type of basic force that operates throughout the universe. We can find a couple of bar magnets or a horseshoe magnet, right? Here is a horseshoe magnet that has magnetic force which attracts the iron nails, right? So here this force acts. We can see some more examples. This is a bar magnet, right? And it has north and south ends. You can see here this N is north and this S is south. So basically we can say that magnetic energy flows from north to the south end. Magnetic fields are not fully understood, but the basic principle is that opposite poles attract. Here you can see that there is minus charge. So these are like charges, or these are the like poles. And here we can see the plus. That means these are also like poles, the same ones. So always remember that like poles always repel. they will move away from each other. And when there are poles like plus or minus, or we can say the charges, right, plus or minus, that means these are unlike. The unlike charges attract. That means we can say that if north pole and north pole acts, that means they will repel. If south and south pole acts, that means they will repel. But if north and south pole acts, that means they will attract. Right? So this is one such example that like poles repel and unlike poles attract. Right? We can demonstrate by using the magnets. You can even try it at your home. You can just try to push two repelling ends of the magnet together so that they can feel the force of magnetism at work. Right? And the best example is Earth. Earth has also magnetic field, and that is why we use compasses. Right? So we can say basically that magnets have north and south ends, and the magnetic energy flows from north to south pole. Now we will study about the last force, that is the electrostatic force. Yes, electrostatic force is the force of attraction between the charged particles. So we can basically say that definition of electrostatic force is when two charged objects or two charged particles interact with each other. And one such example is of that of an object which is getting an electrostatic charge with a comb or a plastic pen or a ruler, whatever. If we rub the pen or a ruler or a comb against our clothes, or if we rub against our hair, like if we are combing the hair, right? So after combing the hair, what will happen? Yes. If we run a comb through dry hair, the comb becomes charged and is able to attract the tiny bits of paper which you can see here, right? These are the tiny bits of paper which are attracted towards this comb, right? So always remember that whenever we run a comb through dry hair, okay, not an oily hair, right? So whenever we rub it or whenever we comb our hair, the comb becomes charged and is able to attract tiny bits of paper. So this attraction is termed as the electrostatic force. So this is a force of attraction between the charged particles. Yes. The second example is, what happens when we rub the pen or a ruler against our woolen cloths? Yes. The pen or ruler will get charged by rubbing it on woolen clothes because it has been charged. And that is why it produces electrostatic force. In the same way, there is one more example. What happens when we rub balloon against our hair? That should be dry hair, not an oily hair. There, yes, we can feel that our hair rise as we slowly lift the balloon, right? And there are some more examples, like there are some situations where the effects of electrostatic charges can be observed daily, right? So these are some everyday situations. One everyday situation is when we get a plastic packet and the plastic sticks to us, right? If you get a plastic packet, the plastic will stick to you. This happens because the packet rubs against lots of things which gives it an electrostatic force or an electrostatic charge. And that is why this force acts. Another everyday situation is that when you remove your school jumper over your head and your hair will stand on end, or moving a nylon bag over the head, and we can notice that our hair will stand on end. Even a third day everyday situation is, or it could be that when you rub your feet on the carpet and then you immediately touch a metal door handle, you will get a small shock. So this is due to the charge. It gives electrostatic charge, and that is why this electrostatic force is able to see, right? So we are being able to see such type of forces in our everyday situations, right? So this was all about the force, the types of forces and the effects of forces. I hope you enjoyed in today's session and learned about forces. I'll definitely get back to you in the next session with lots of more things about force, work and energy, right? So we'll meet in the next session. Till then, keep learning, keep enjoying, children.